Hi, I'm Rudraksh, and in today's video I'm going to talk about my final project for graphical application development with Thomas Fernandez. In this program there are basically there's basically a particle swarm which is a method. A particle swarm optimization is a method that is used to find out solutions for functions, and I'm using the particle swarm optimization to find out the highest peak for a sombrero function. Let's start the program and see how it works. So I'm sorry for the grab. Okay, so these are my particles. As you can see, there are more than 1,000 particles on the screens, and each particle is trying to find out the best position for the sombrero function, which is the highest peak of the function. And the big squares that you can see over here, they are those squares that found very good positions from the start of the program. The one that you see over here in pink is the one that represents the highest position that is found by the particles so far. And the yellow particles that you see over here, the one yellow over here, and there must be another one somewhere down, which is must have just went out of the screen. But there are two yellow particles that randomly appear or disappear, and that attract the swarm and like guide the swarm to move around on the screen. The swarm moves around on the screen and tries to find out which is the highest position that is obtained on the sombrero function. The sombrero function cannot be seen on the screen, but it's like an equation which gets evaluated for each position of the particle, and for that a given height is obtained, and if that height is better than the swarm best, then that height becomes the new height that all the particles get attracted to, which we can see in the side video or side node, where we can see that so far this is a location 0.0468, 0.0925. At this position, this is the maximum height of the sombrero function that was obtained by the particle swarm, which is represented by this pink dot on the screen. The particle swarm is attracted also is moves on its own and also gets attracted by this repulsors and by the global best, which is the swarm best. So both of these factors get factored into their position along with their own velocities, and then the fact that they move around gets added into the equation, and they keep on moving on the screen trying to find out the best position possible for the sombrero function. And this basically is my graphical aspect behind the genetic algorithm, which is particle swarm optimization, that is running to produce results for finding out the maximum height for the sombrero function. So this is my project for graphical application development, and this is my graphics part of it. I hope it looks beautiful. I mean, it's kind of a messy, more like a zigzag movement kind of particle thing, but it is actually performing a function. The entire swarm is trying to find out the best location for a given function, which can be an optimal solution towards a problem, or it can be finding out the backtracking, using backtracking and finding out the best weights for neural networks. The particle swarm can be used for a varied amount of solutions, and I'm using it for the sombrero function. So that's my function, that's my program, and these are the graphics. I hope it looks beautiful, and I hope you enjoyed watching the video, and have a nice day. And as always, thanks for watching.